Okay. So I guess no. Now fine. Now today, what I have planned that I discussed about one another very important feature of Prolog, and that is controlling backtracking. Okay. Now, so far the programs that we have seen, I hope you get the idea that uh, instead, even if Prolog satisfies the goal by one answer, it then also it tries to find out the other alternative solutions, right? This is the inherent feature of the Prolog, that it automatically backtrack, right, for satisfying a goal. Even if the goal fails, then it is very much obvious that it will try for some other solution. But even if it gets the solution, even if the goal is satisfied, then also Prolog tries to find out the other solutions, right? But this is very good, this feature, but there are some situations for which this uncontrolled backtracking will make the program inefficient as far as the time complexity is concerned. Although for the very small programs you can't identify it, but there are some situations where by seeing the program you can find it that there is no need to go for checking the other alternatives, right? So for those situations we have a way to control that backtracking. We can prevent Prolog for going to backtrack, right? And for that we have a goal, special goal, that is called cut, and that is symbolized by this symbol, exclamatory sign, right? So this is the, so what is the job of this cut? What is the role of cut? The cut is used to prevent Prolog for unnecessary backtracking, right? Where backtracking is needed, then I have to I there is no use of this. But when you can guess that in this situation I can prevent Prolog for going to backtrack, then you can use this cut. Okay. Now let me show you some examples. Now see, uh, here I have given 3 rules. Okay. Consider the following 3 rules. What the rule 1 says, that if x less than 3, then y is equal to 0. If x is greater than equal to 3 and less than 6, then y is equal to 2. And if x is greater than equal to 6, then y is equal to 4. Okay. So these are the 3 rules are given, and you are asked to write Prolog program to implement these 3 rules. Okay. Very easy. I guess you find that these are not very difficult. So I have taken a function, a relation fxy, and I have written the program like this. Is it okay? Are you getting it? Okay. So now, after writing this program with these three relations, 3 instances of this same relation. So x comma 0 if x less than 3. So what does it mean? That if x less than 3, then y is equal to 0. If this is happens, then y is equal to 2. If this happens, then y is equal to 4. Right? Now, what I am given, that my goal is this: f1 comma y comma 2 less than y. Right? So what I am asking to you, that without writing the program, now can anyone tell me what will be the result? What will be the output of this goal? Can anyone tell me?
It should be false.
Fine. Why? Why? Can you tell me the reason?
Yes, sir. So as x is 1, so rule number 1 should satisfy. If x is less than 3, then y is 0. So here we are asking if y is greater than 2. But y is 0 and y is
Right.
not greater than 2, so we get false.
Very good. Very good. So there are two goals, right? So first is f1 comma y. So when Prolog goes for f1 comma y, so x is 1. So this condition is satisfied. So it instantiates this y is equal to 0, right? Now see, so with this value of y, it tries to satisfy 2 less than y, right? But 2 less than y is not true. So that's why the answer will be false, right? Now see, what will happen? Why I am given this, I have shown you this example. Now this example, the rules that is written over here, these are the mutually exclusive conditions, right? If one condition is satisfied, then there is no point to check for the other two conditions, right? But what Prolog will do? Prolog will try to satisfy, even if it satisfies this one with the answer false, Prolog will try to satisfy the other two goals also, other two conditions also, okay, to find out the other solutions. Okay, now that is not required. This is the situation where, since the conditions are mutually exclusive, if one condition is satisfied, then we can prevent Prolog to go for backtracking, right? Now let's see. So this is the way how it is going. So this rule is satisfied with this rule, it gets the answer no. Now even if this is satisfied, then also Prolog tries to satisfy these two also, right? Now with that, the answer will be same, the answer will be no, but there is no need of that, right? So here is the point where we can use that cut. We can place the cut over here, that so that the Prolog will not try these two branches, right? Okay. Now the question is that the question that will come, that how to do this. Okay, so how to do this? So this is the way how we can do this. Now what is the procedure, what is the mechanism that is taken by this cut? I will come to that, but just to see the modified program, okay, of the same program, the modification. What is the modification? So after x less than 3, I place the cut. So what does it mean? So as soon as the control reaches to that cut point, then all the other possibilities will be cut it out. That means whatever the value it will get, that will be frozen. Now if with this program, if I ask the same goal, then the answer will be same, right? There is no point that in the earlier case I am getting the different result, here I will get the different result. That is not the case. The answer will be same, but it did not go to check the other two conditions, right? Now here from this version, I am another improved version is written like this. So what is the meaning of this? Now see, if x less than 3 is not true, then is it necessary to write this condition again? Because if x less than 3 is false, then it is obvious that it x greater than equal to 3, right? Are you getting the point where I am saying? Okay, so
What does colon stand for?
Sorry,
What does exclamation mark stands for?
exclamation প্রথমেই বললাম, I have saying in the first slide that exclamatory marks, it is a symbol of the cut, that is the cut. Okay, so cut, that I already told you that cut is used to prevent prologue for the backtracking. Okay, so what is the meaning of this? So as soon as your control reaches to this point, now when it will reach to this point, if this condition is satisfied, if this condition is not satisfied, then prologue will come to satisfy the next one. There is no problem of that. But if this condition is satisfied, then the control reaches to this point. Now as soon as the control reaches to this point, then it means that we are preventing prologue for the backtracking, right? Because the reason is the conditions here are mutually exclusive. So if this condition is satisfied, then there is no point to check for the other conditions, right? Okay, now from this version we have modified the version over here. How we get the modified version? The reason is, if x less than 3 is false, then it is automatically mean that x greater than equal to 3 will be true. So that's why we don't need to write this one. So we can directly write x less than 6. Similarly, if x less than 6 is false, then it automatically means that x greater than equal to 6 is true. So that's why we can write this one. Okay. Now with the improved version, with this improved version, now if we omit this to cut, now tell me what will be the answer of this goal. Now you just take or consider this program. Okay, what I have done here with the modified version, I have omitted the cut. So if I omitted the cut and then I have given this goal, now tell me what will be the answers that you will get. Can anyone tell me what are the answers?
0 to 4.
Okay, fine. Any other answer? If anyone can try. Okay, Vedika says 0 and 2. Fine. Any other answer? Anyone? If anyone. Okay. Okay. Can anyone try? Want to try? Okay, fine. Now see, why you guys think about? Yeah, Neha also says 0 to 4. Very good. Now see, now let me explain. Now, why those who have thought about 0 and 2, why you have thought 0 and 2? Why not 4? Is that the only reason that there is no such condition written? Is that the only reason? What is the reason? Just I want to know. Those who have said 0 and 2. Even Devdeep can also say, Devdeep and Vedika says that. No condition. Yeah, okay, fine.
So, but I had a doubt. So that's the base condition. It can run for absolutely no condition. Right.
Yeah. If there is just not 4 because they are x greater than equal to 6. Yeah. No. See. Your goal is f1, y, right? So now what will happen? So it starts as far as the principle of the prologue. So prologue starts from the first goal, first relation. So this condition is satisfied. So it returns 0. Then it tries to find out the alternatives. So here there is a second alternative, and it finds that there is a condition x less than 6. Then also 1 is less than 6. So it returns 2. Now again, prologue comes over here, right? It comes over here and to find out that whether it can be possible or not. Now here it finds that there is no condition. So if there is no condition, so it means it is unconditionally true. Whatever the x value is, that it will return 4, right? So it will return all these three values, 0, 2, and 4. Are you getting? If there is no condition, so it means it is a fact, right? It is nothing but a fact. So fact means what? It is an unconditionally true statement. So unconditionally true statement means whatever the value of x is, it returns a result, right? So that's why it will give you all the three results, 0, 2, and 4, right? So now see the difference between this program and this program. Here, this program is without cut. This program is the with cut. Now, when you place the cut, when the first condition is satisfied, now see, if you give the goal f1, y, what will happen? f1, y, 1 less than 3, and as soon as this condition is satisfied, it returns 0, and it reaches the cut. It automatically, it is actually prevents Prolog for checking the other conditions. So it will stop over here. Are you getting? Yeah, for this one, only the result that will be coming out is 0. Huh? Didit is saying something. Yeah. Which one? This one? Huh. So here, what will happen? If you give the goal like this, f1, y, so what will happen? It tries to find out, Prolog tries to find out whether this condition is satisfied or not. Now, since this condition is satisfied, the control reaches to this cut. As soon as the control reaches to this cut, what will happen? The meaning is, we prevent Prolog not to check the other two conditions or other instance of this relation. So it will stop over here, right? Now suppose, so that's why only the result that will coming out will be 0. Now suppose you are giving the value of x. Suppose you are giving the goal f 4, y. Now what will happen? If it is 4, y, then it finds that this condition is not satisfied. So if this condition is not satisfied, then the control cannot reaches to this cut. So it means then it will check this alternative. So in this case, your condition is satisfied, 4 less than 6. So as soon as this condition is satisfied, the control reaches to this cut. So as soon as this control reaches to this cut, for this case, it will return 2, right? It will return 2, but it will not come over here because it reaches the cut, and cut will prevent Prolog to go for the next alternative. Are you getting? Okay, now even if you are not getting it, I have another way to explain this thing. Now let me explain this thing in a different way, with a different example. Now what I have seen over here. Now suppose this A. These are arbitrary relations. Okay, so A is a relation which is written. There are 3 goals, B, C, D. I am not bothered about B and D. B and D is defined somewhere else. We are not bothered about that. I am bothered about the C. Okay, there is 2 alternative definitions of C. One is like this, another one is like this. Okay. Now I have given the goal A, right? Now as soon as I given the goal A, so what will happen? Prolog comes over here. It satisfies, suppose it satisfies B, right? And after satisfying B, it comes to satisfy C, right? Now, as soon as it comes to satisfy C, so what is happened? So this is the first instance of C. So in this C, suppose P, Q, R, all three are satisfied. Now, as soon as these three are satisfied, control reaches to this cut. Now, what has happened? Listen very carefully. As soon as the control reaches to this cut, all the results that you got for P, Q, R are frozen. Right? Prolog will not go for finding the any other alternatives of P, Q, and R. Okay. Now, as soon as the control crosses this cut, there are another three goals, S, T, U. Now, there will be backtracking between S, T, U, but there will not be any backtracking of P, Q, R, as well as Prolog will not go to check the other alternatives of C also. Are you getting? Is the explanation okay that I have given?
Yes, understood.
Okay, fine. Very good. Now, if the idea is clear, I have a very small exercise for you, but one request I have, you do this exercise without writing the program. Okay? So, without writing the program, by seeing this, you try these three questions and write me the results in the chat. So these are the facts and rules that is given, P1, P2, P3, and these are the three goals. Okay, and you try one goal at a time and give me the answers. Okay, without writing the program. Okay, so yeah, so let me start with the first one first. Those who are doing, you just do it and write it to me. There is no issue. For the first one, that means number one, the goal was Px. The goal is Px. Now the answers that I am getting for the first one, all the answers are correct. For the first one. So what will be the answer? See, Px, right? So now Prolog will try to satisfy this one. So it starts from one. Starts from this one. P1. So x will be instantiated by 1. So it returns x equal to 1. Right? Now there is nothing over here. So Prolog will try to go for the find the other alternative solutions. So here it comes over here P2. So x will be instantiated by 2. But there is a condition and there is a cut. Right? So as soon as this cut reaches, so it returns x equal to 1, x equal to 2. And as soon as it reaches to this cut, then all the values that it got, that will be frozen, right? So Prolog will not go for trying this alternative solution. Okay. So for 1, your answer will be x equal to 1, x equal to 2, right? So these are the results that I got for the first one, and these are true. Now coming to the second one, Px comma Py. Now Px comma Py, the answers that I got, one answer is correct, absolutely, but other answer like Aditi, the answer that you give me is partly correct, not fully correct. And I got an answer from Neha that is true. Okay, so let me explain. Px comma Py, yeah, Px comma Py. Now Px, right? So Prolog will try to satisfy Px first. So px means what? Px means it starts from here. So x will be instantiated by 1. Now with this value of 1, with this value of x, Prolog try to satisfy py. Now when it goes to satisfy py, again it starts from here, right? It starts from here. So y will be instantiated by 1, and then it comes over here, y will be instantiated by 2, and then it will be cut. So what is the meaning? X equal to 1 with this value of 1, this value of x equal to 1, there are two values of y. Y is equal to 1, y is equal to 2, right? Now it again go for px. So p, it got x equal to 2. With this value of x, it again got y is equal to 1, y is equal to 2. So there will be 4 solutions. 1, 1, 1, 2, 2, 1, 2, 2. Right? Okay. Now I have less than 1 minute left. So you guys please join immediately. Okay. I am stop sharing over here. The second one is clear. Anyone having any issues of on the second one, px comma py? There will be 4 solutions. X equal to 1, y is equal to 1, x equal to 1, y is equal to 2. Similarly, y is equal to x equal to 2, y is equal to 1, x equal to 2. Possible for the second one, right? And what about the third one? I have not. So can I get more answers for the third one? Px comma after making x equal to 1, it will stop finding other values for x and only change y, right? So what will be the solution? So basically, out of the 4 solutions of the second one, the third one will take the first 2, right? So what will happen? Px, right? Px. So it's goes to satisfy x, px. So it will get x equal to 1. Now with this x equal to 1, it proceeds, and as soon as it proceeds, it finds a cut. So as soon as it finds a cut, then the values that it got for x, that will be frozen. So x equal to 1, right? It will not go to find out the alternatives of x, right? But there will be the backtracking between y, right? So px, so that means x equal to 1. Now with x equal to 1, it tries to satisfy py. Now again it starts from here. So it got y equal to 1, and then it comes over here, got y is equal to 2, and stop. So the solution is x equal to 1, y is equal to 1, x equal to 1, y is equal to 2. That's it. Right? Are you getting any doubt, any confusion? Tell me. Sure. So third one is what? Third one is saying px comma cut. So first it as like this. Here also it goes to satisfy px. So it starts from here. It got 1 over here. So that means x will be instantiated by 1. Now as soon as it instantiated this x with 1, That means this will be satisfied. Now with this, it move on. Now, as soon as it reaches to this cut, as soon as it reaches this cut, then the value that it got for x, that will be frozen. So here it will get x equal to 1, right? Now with this x equal to 1, it tries to satisfy py. Now for py, again the same situation happened. It starts from here, it got 1, so y is equal to 1. Then alternatives, y is equal to 2, and then stop. So the solutions are x equal to 1, y is equal to 1, x equal to 1, y is equal to 2. So the 4 solutions that you got in case of 2, out of these 4, here it will got only the first 2. ঠিক আছে? আচ্ছা, প্রণয়, what is right? Fastest second solution টা একটু repeat করবেন. What is the fastest second solution means what? For the first one, there are 2 solutions, x equal to 1, x equal to 2. Now why x equal to 1? So it starts from here, it got p1, so x equal to 1. Now Prolog automatically goes for backtracking, that means alternative solutions. It comes over here, p2, so x equal to 2, but it will not go for this one because there is a cut. So that means it will stop. So that's why 2 solutions, 1 and 2, the first one.
মানে স্যার এই যে ফ্যাক্টোরিয়ালটা আছে বলে মানে
ওটা ফ্যাক্টোরিয়াল নয়, this is a cut. This is a cut, not factorial. It's a cut.
Okay, sir. Cut.
Okay, so this is all about for cut. Now the question is where you can use it. Okay, so let me check one thing. There are a lot of occasions where you can use it, where there are mutually exclusive conditions, right? Now suppose this one, we have done this program finding maximum of 2 numbers, right? And what we have done, x greater than equal to y. Now if x is greater than equal to y, if it is satisfied, is there any way or is there any reason to check whether x is less than y or not? Are you getting my point, what I'm trying to say? If x is greater than equal to y is satisfied, now what will happen in this program? For the 2 values that you have given, Prolog will check this condition. Even if this condition is satisfied, it comes over here to check whether x less than y or not also, right? But this is not required because these are the mutually exclusive condition. Now what we can do, how we can modify it? Can anyone tell me how we can modify it using cut?
So simply after the first condition, comma and exclamation mark.
Okay, comma and exclamation, but that's not all. Even if you place the cut, then you don't need to give this. Then you don't need to give this condition. Am I getting?
Yes, sir.
Because if x greater than equal to y is false, then it automatically means that x less than y, right? So it comes here and print it, right? And if x greater than equal to y is satisfied, then there is a cut. So that means it will not come over here, right? Okay. Now there is other applications also like this. I hope you remember removing the duplicates, right? Removing the duplicates. If x is a member of y, is there any reason to check whether x is not a member of y? So here also we can modify it. So how can I modify it? Can anyone tell me this program? Yeah. So this condition will not be removed. Right? So this is the application of cart, where there is a, so you have to, one thing very much I want to end this class by saying one important point, that only using the cart is not the job. Okay, because if you place the cart, actually the placing the cart is much more important. Okay, if you place the cart in a wrong position, in a wrong situation, you will get the wrong result, right? So if you use the cart, you have to be very much sure about that, because if you place the cart in a wrong situation, then some of the results will not come, right? So you have to be very much sure about that when you are using the cart. And when you use it, then you have to make sure that where you have placed it, the placing of the cart is also important, right? So now since you are now familiar with the cart, now you try to use the cart in possible occasions, in the occasions where it suits, right? Clear? Is it okay? Okay, so that's it for today. Now again I repeat that the jobs that was given, the pending jobs, the pending works, you please do it and let me know what is the status, right?